Welcome to the VCE VXRail Appliance Administration and Management course. This course provides details for managing and monitoring a VCE VXRail appliance. It explains VXRail administrative tools as well as the features and operations for the components that make up the solution. This is the agenda for the course. Please take a moment to review it. The course materials include the Student Resource Guide and the Student Lab Guide. We've also suggested some reading material that is referenced in the course. Please take time to complete the assessment and course evaluation at the end of the training. Welcome to the VCE VXRail Appliance Architecture Overview. The objectives for this module prepare you to describe the VCE hyperconverged infrastructure options, explain the VCE VXRail appliance architecture, and identify the components that make up the VCE VXRail appliance. VCE VXRail appliance provides ease of deployment and management, which provides simplicity that enables customers to leverage VXRail in their data centers, branch, or remote offices where they may not have deep technical administrative expertise. Each VXRail appliance model supports a mix of flash and HDD storage media. The appliances can also be configured in all flash configurations. Each appliance consists of 4 nodes, and each node contains CPU, storage, and networking I/O resources. Appliances can be clustered together up to a maximum of 16 in a cluster, which provides for very high levels of scalability. This also provides a more granular scaling of CPU and storage resources. Built-to-order hardware with configurations to match any use case, the VXRail appliance offers choice of next-generation Intel processors, variable RAM, storage, and cache capacity with increased horsepower per appliance. This allows customers to buy what they need now in providing a predictable pay-as-you-grow approach for future scale-out. The VXRail appliance has an entry-level system with cost-effective network support. There is also an all-flash family for environments that need the performance of flash with on-demand capacities. VCE combines hardware and software to create a hyperconverged cloud appliance designed to be extremely agile, simple to manage, highly reliable, offering predictable performance while being cost-effective. The VXRail appliance achieves all of this by using a VCE branded 4-node enclosure, an EMC or customer provided network switch, and VCE VXRail Manager software. Partially populated appliance with less than 4 nodes can be configured for an appliance that joins an existing cluster. This is done via a hardware upgrade kit that is made available to add a node with its associated SSD and HDD drive packs to an existing partially populated appliance chassis. VCE VXRail Appliance is architected with VMware virtualization, VMware operations, and VCE management software. The software stack comes pre-installed and simply requires running a configuration wizard at the customer site to integrate the appliance into the environment. Once the appliance is built, VXRail can be accessed by pointing a browser at the VXRail Manager IP address. VXRail Management provides a dashboard to view all nodes that make up the VXRail cluster and their storage. VXRail Manager provides a software stack for software-defined data center, or SDDC. Building blocks include compute, network, storage, and management. VXRail Manager streamlines deployment, configuration, and management for easier initial setup and ongoing operations. VXRail Manager also provides integration for EMC services and support to help you get the most out of your VXRail appliance. With VXRail Manager, you can monitor system health with deep hardware intelligence and graphical representation, view appliance software versions and updates, access EMC online support and e-services, access VXRail community resources such as the user forum and knowledge base, and use the VXRail market to access qualified EMC software products. The VMware vSphere virtualized infrastructure is managed by VMware vCenter Server 6.0. The VMware vCenter Server provides the management of vSphere deployments and the rapid provisioning, monitoring, and controlling of virtual machines. In VXRail deployments, all the ESXi nodes in the appliances and the vSAN data store are backed by a single instance of the VMware vCenter Server. The VMware vCenter Server framework is installed as a single virtual machine configuration on the primary VXRail node. The vCenter Server appliance is created with an optimal configuration to support the system requirements for the installation of the underlying components of vCenter Server. As an alternative, you can also choose to connect to an existing vCenter Server in your environment. VMware Virtual SAN is integrated in your VXRail appliance to provide software-defined storage or SDS. Virtual SAN is not a VSA, but is embedded in the ESXi hypervisor's kernel I/O data path. As a result, Virtual SAN can deliver higher performance with minimum CPU and memory overhead. Virtual SAN pools the VXRail appliance's internal disks on the ESXi host to present them as a single data store for all hosts in the cluster. Virtual SAN uses a highly available, distributed, object-based architecture. Virtual SAN mirrors and distributes the individual VMDK across the data store. With VXRail all-flash systems, vSAN 6.2 delivers efficient nearline deduplication, compression, and erasure coding capabilities. With vSAN, different VMs can have different service levels, so self-tuning data store storage is governed by service level policies. Customers have the ability to dynamically change storage policies on the fly without interrupting service levels. Applications drives storage needs via policies, and Virtual SAN self-tunes underlying infrastructure. Also included in the VXRail appliance is VMware vRealize Log Insight. It delivers real-time log management for VXRail appliance with machine learning-based intelligent grouping, high-performance search, and better troubleshooting at scale across physical, virtual, and cloud environments. VCE VXRail Appliance is fully compatible with the entire VMware portfolio, such as VMware vRealize Suite. vRealize Suite is an optional component to the VXRail appliance. VCE Vision Intelligent Operations is health and lifecycle management software embedded in the VCE converged and hyperconverged infrastructure systems. It is an optional component to the VCE VXRail appliance. You will need to have a vBlock running Vision and you will then use that instance to connect to VXRail. EMC Secure Remote Services, or ESRS, Virtual Edition is a two-way secure remote connection between your EMC environment and EMC customer service that enables remote monitoring, diagnosis, and repair, assuring availability and optimization of your EMC products. It is secure, high-speed, and included in all enhanced and premium support agreements at no additional cost. With ESRS, EMC can periodically monitor the appliance and will be notified of failure, enabling support to take preventative measures to help avoid downtime. When coupled with ESRS, EMC 24/7 support is incredibly simple. All appliance issues, regardless of whether they are hardware or software, are handled by EMC support. EMC support can be reached directly from the VXRail Manager interface, where a user can research the issue via the online support community, chat with EMC support, or by phone, getting issues resolved quickly. The addition of flash and single node scaling delivers even greater flexibility and customer choice with more of a build-to-order model. The extra small option, VXRail 60, and the single node scaling also create additional flexibility in terms of initial purchase as well as upgrade costs. The VXRail appliance architecture is a distributed system consisting of a common modular building blocks that scale linearly from 1 to 16 2U 4-node appliances up to 64 nodes in a cluster. Multiple compute, memory, and storage options deliver configurations to match any use case. Note there is no mixing of all flash and hybrid in the same cluster. VXRail configurations and capabilities extend the value of VXRail. With the flash options, you can have up to 76 terabyte flash in 2U, deduplication, data compression, and erasure coding. You have the flexibility of a single node scaling in capacity expansion while having the ability to integrate with an external vCenter as well as NSX support. VCE has introduced the VCE VXRail Appliance as a solution to meet the requirements of customers looking for simplified data center deployment, management, and scale. Its architecture is made up of VCE branded server hardware, and VXRail with vSAN is a solution that provides a new virtual infrastructure that is simple to deploy, operate, expand, and to perform maintenance. Welcome to VCE VXRail Appliance Monitoring. The objectives of this module are to understand the base configuration and know how to monitor the environment using multiple user interfaces for BMC, VXRail Manager, and vSphere Web Client. Appliance management automates cluster operations, automatic deployment and configuration, scale-out, and non-disruptive updates. Designed around simplicity with a clean user interface and automated management. We see the easy-to-use interface with our first access to VXRail at installation time. The VXRail user interfaces also provide a high-level view of the status of the environment. VXRail Appliance is designed to simplify everyday management tasks and activities, even monitoring. VXRail Manager provides efficient management through easy-to-follow simplified set of processes and procedures. VXRail offers a baseboard management controller or BMC interface for monitoring the physical state of the appliance through an independent connection. The BMC interface is through an Intel Remote Management Module 4 or RMM4 port that provides access by way of a LAN or Internet connection. When the VXRail appliance is shipped from the manufacturer, the shared BMC interface or baseboard LAN is disabled and the dedicated BMC interface, the Intel RMM4 LAN port, is enabled. You can access the BIOS in BMC through either a locally attached VGA monitor and keyboard or a remote console if the RMM port is assigned an address by your network DHCP. The RMM port supports Ethernet speeds up to 100 megabits per second. The switch you connect to for the RMM port must also support 100 megabits per second. You can use remote management to look at BIOS information, launch a console to the node, or power cycle a node. However, you must adhere to the power guidelines in the VCE VXRail Appliance product guide unless otherwise instructed. All VXRail cluster shutdowns should be handled by the cluster interface, which is under the VXRail Manager. This enforces proper cluster shutdown. Here we see a sample initial sign-on screen along with the remote control screen. The VMware vSphere virtualized infrastructure is managed by VMware vCenter Server 6.0. The VMware vCenter Server provides the management of vSphere deployments and the rapid provisioning, monitoring, and controlling of virtual machines. In VXRail deployments, all the ESXi nodes in the appliances and the vSAN data store are backed by a single instance of the VMware vCenter Server. The VMware vCenter Server framework is installed as a single virtual machine configuration on the primary node or connected to an external vCenter environment. VXRail Manager monitors its virtual infrastructure also, which we'll be discussing in this presentation. From the vSphere web client, you are able to inventory, monitor, and manage the entire virtualized environment. This includes the cluster, network, virtual distributed switch, data stores, virtual SAN, ESXi hosts, and virtual machines. You are also able to get information on the hardware environment when needed. The vSphere web client is a powerful interface which lets you view an initial summary of the ESXi host on the Summary tab after selecting the ESXi host in the left navigation pane. This is where you can start. From here you can get more detail related to each ESXi host. You are able to review issues, performance, tasks, events, hardware status, and view the logs for a particular host. The vSphere web client lets you look at a virtual machine at a high level with the Summary tab, but also lets you drive down into more detail. At some point, you may need to monitor a specific aspect of a VM, and the vSphere web client lets you do this. By selecting the VM in the left navigation pane, you can navigate across the tabs, Summary, Monitor, Manage, and Related Objects, all related to the chosen virtual machine. Choosing the next tab, Monitor, gives you more options looking at issues, performance, policies, etc. vSphere Web Client lets you view a VM at a high level, but it's always good to know you have the details available if you ever need them. On the vSphere Web Client, navigate from the Home icon to Storage. This will present a high-level view of the storage and its entities. You can start with the Summary tab, always a good place to begin. You'll notice 4 data stores in this 4-node appliance example we're looking at. There is one for each node in this cluster. You'll also notice the Marvin Virtual SAN vSAN entity. You can select any of the devices in the left pane to see summary information on the right-hand side. This is a good place to see their storage allocation, and you can page down to get more details. On the vSphere Web Client, staying with the vSAN Selection and Monitor tab, you can see 4 options: Issues, Performance, Tasks, and Events. Each gives you more detail if ever needed. In the Performance Space option, you can see how much space is in use for multiple entities such as swap files, virtual disk, free space, etc. The VXRail Manager interface provides a simplified way to perform some of the common tasks usually done in vCenter. While vCenter remains available for all management tasks, VXRail Manager monitors overall system health, gathering log bundles and viewing events. The various areas on VXRail Appliance Management can be accessed by the simple navigation bar on the left side of the interface. After logging into VXRail Manager, the user interface presents the VXRail homepage. The dashboard page displays the overall system health, event history, support, and VXRail community information. When management tasks are required using vCenter, there is a convenient link and launch icon in the upper right-hand corner of the VXRail homepage to launch the vCenter web client. The VXRail Manager Support tab displays support status information as well as support resources and links. Let's take a look at these closer. Last heartbeat displays the date and time of the last successful heartbeat sent by your VXRail appliance using ESRS Connect Home. Note, ESRS must be installed and enabled for this to work. Chat with Support lets you open up a chat session with a support representative. Open a service request navigates to eServices where you can open a service request. View the last configuration sent displays the most recent VXRail appliance configuration data sent using ESRS Connect Home. Again, ESRS must be installed and enabled. Downloads displays available applications and add-ons available for your VXRail appliance. VXRail Community Updates displays the most recent activity for the VXRail series community forums. The knowledge base lets you search the support knowledge base and access VXRail series support articles. The VXRail Manager Events tab displays a list of current system events. The system event list displays all the VXRail appliance events. The event details displays information for the selected event in the system events list. If there are critical events detected, the health icon displays the number of unread events in red in the navigation bar. The Logical tab of the VXRail Manager Health window displays information about the hardware components of your appliance. A graphical representation of the appliances in your cluster make it easy to navigate for event and status information. At the top, you see the VXRail serial number that is assigned. Here in this example, it starts with EMC8SQ. If there are multiple appliances in one cluster, you will see an entry across the top for each one. Each appliance is selectable to review its components information. On the top half of the screen, we see the main health timeline for storage IOPS, CPU usage, and memory usage, with additional numbers in each category providing a good high-level view of the appliance use. Under the main health timeline, you'll find the storage information providing capacity, used, free, and provisioned. When you scroll down the logical health page, you can see the individual nodes for the selected appliance. Each attribute line for a node can be expanded. Notice here that we have expanded the NIC information for node 1. The Physical tab of VXRail Manager Health window displays information about the hardware components of your appliance. A graphical representation of the appliances in your cluster makes it easy to navigate for event and status information. Use the Physical tab to view the following: appliances in the cluster, view appliance status information such as ID, serial number, and so on. Individual appliance components, drill down to see status information for appliance components such as disks, compute nodes, and power supplies. The Features tab of the VXRail Manager configuration window displays information about the applications and add-ons currently installed on your VXRail appliance. It also allows you to download updates for those components. Use the Features tab to view the following: installed software and add-ons. The list here displays the name, description, and installed version for the software and add-ons installed on your VXRail appliance. Software updates. If an update is available for an application, an update button is displayed. When a new version of an application is available, Config in the left navigation bar displays a highlighted number. The General tab of the configuration window displays information and settings for your VXRail appliance. Use the General tab to view the following: About VXRail Manager. Displays the current version of VXRail Manager software running on your appliance. Set Support Account. Displays the linked support account and allows you to link or change to a new account. Log Collection lets one generate a new log bundle. One may want to use this if something is being seen during monitoring to drive down into more detail. Enable EMC Secure Remote Support. This displays whether or not ESRS is enabled on your VXRail appliance. And finally, choose your language. Select the language used in VXRail Manager. Continuing down the same page under the General selection, we can review how some options are set for Configure Network Environment Settings and Suppress Cluster Monitor. Note there are other options on this page that will be discussed later in this course: System Diagnostics, Shutdown Cluster, and Choose Your Language for the VXRail Manager UI. Each ESXi node uses one virtual distributed switch that contains multiple port groups, and the VDS spans across all nodes. A port group is an aggregate of multiple ports with a common configuration. Each port group is identified with a network label. In VXRail, traffic can be tagged at the port group level. In this example, VLAN ID 270 is used on the management network, vCenter server network, and Marvin management network port groups. VLAN ID 30 is used for vSAN port group, and VLAN ID 20 is used for vSphere vMotion port group. At the top of rack switch side, the switch port that is connected to the ESXi node must be configured to accept the tagged traffic. This will occur if the port is configured to be in a trunk mode and configured to allow the VLAN traffic to pass through. If this is true, the switch will accept the tagged packets, strip off the VLAN tags, and forward the packets to their destination. If VXRail is not configured to use VLANs, the VLAN ID will be 0. Besides monitoring the NIC from VXRail Manager, you can also view its health in vSphere. From the vSphere web client, navigate to Network, then select the VDS in the left pane. Select the Monitor tab, then Health. You'll notice here the status of each node and its VDS status, which is showing connected. After the installation of VXRail is completed, the Log Insight VM can be seen in VMware vSphere's list of virtual machines. The Log Insight VM can be managed with a browser by logging on at the IP address set for Log Insight during the VXRail installation. The default username for Log Insight is admin, with the password set for vCenter during the VXRail installation. The Dashboard tab contains dashboards and content pack dashboards. On the Dashboards tab, you can view graphs of log events in your environment or create your custom set of widgets to access the information that matters most to you. On the Interactive Analytics tab, you can search and filter log events and create queries to extract events based on timestamp, text, source, and fields in log events. Log Insight presents charts of the query results. To learn more about Log Insight and its function, please see the documentation at vRealize Log Insight 3.0 Documentation Center in the provided link. VXRail Manager is used to monitor the appliance nodes and resources. vCenter is used to manage the VMware virtual infrastructure and to create and manage VMs. The vSphere web client lets you drive down into more detail about a node, VDS, network, and virtual machines. Log Insight provides interactive analytics by using queries. Welcome to VCE VXRail Appliance Security. Upon completion of this module, you should be able to understand the different types of security, vulnerabilities, and challenges, be able to discuss security methodology, and be informed how VCE Vision can assist in security compliance. We really can't overstate the constant struggle with data protection. How many data breaches have occurred in the recent past? Too many to even list. And despite this, enterprise environments still seem to have trouble maintaining a secure data posture. Just look at the credit card industry. It implemented a whole host of really very strict security standards, and yet 80% of initially compliant organizations had drifted into non-compliance within a year or two. The bottom line is that the more complex virtual and cloud-based infrastructures become, the more vulnerable they can be. Especially in a multi-system environment, security needs to be implemented both at the component level and at the infrastructure level. VCE systems depends on layers of security, each one reinforcing the next, because a perimeter security is not enough. This takes place at manufacturing. Each component is built, integrated, and configured under strict security parameters. At the site, VCE Vision sustains a strong security posture with automated compliance technology. VCE ensures a methodical approach to its commitment to building security in its product and solutions development lifecycle, processes, and operation activities by using the standard quality control cycle of plan, do, check as the core to its security framework. VCE utilizes PDCA as the underlying process. VCE utilizes PDCA as the underlying process as security solutions are evolved and added to the portfolio. This portrays a consistent quality improvement story as time progresses and new activities are integrated. The following provides a brief description of each phase of the PDCA cycle. Plan. The VCE ensures a methodical approach to its commitment to building security in its product and solutions development lifecycle, processes, and operation activities by using the standard quality control cycle of plan, do, check as the core to its security framework. VCE utilizes PDCA as the underlying process. VCE utilizes PDCA as the underlying process as security solutions are evolved and added to the portfolio. This portrays a consistent quality improvement story as time progresses and new activities are integrated. The following provides a brief description of each phase of the PDCA cycle. Plan. Establish the objectives and processes necessary to deliver results in accordance with the expected output, the focus. Do. Implement the new processes, technologies, etc. according to the plan. Check. Measure the new processes and compare the results against the expected results to ascertain any differences. Act. Analyze the differences to determine their cause and determine where to apply changes that will include improvement. VCE product development implements these phases in its overarching security framework. The message ensures a clear understanding of activities, solutions, etc., and how they all progress to solve the security and compliance challenges. The phases with brief description of the intent for each are described below and visualized with its corresponding PDCA phase. Architect. Establish the security strategy, define and communicate goals and objectives, establish clear policies and standards, plan and communicate portfolio, etc. Implement. Solutions implementing policy and standard requirements, development of guides aligning with requirements, solutions addressing specific needs, training, and awareness. Validate. Guides and solutions to validate to ensure compliance with policies and standards, tactical guides for specific verticals, vulnerability management, etc. Govern. Guides and solutions to ensure clear view of compliance and risk posture as a whole, solutions on reporting and metrics, integration with existing governance programs. Utilizing this cyclical process, VCE will convey a qualitative, iterative approach to security. The goal is to illustrate the integrated methodology of each phase solution. Of course, to ensure accuracy and validity of each activity, each solution should follow the same cyclical approach. Basically, an approach of quality wheels within the greater framework wheel. The organization structure orgs defines a management hierarchy within the VXRail appliances. The hierarchy is strictly for management of resources and logical objects inside the system, and it has no effect whatsoever on the actual operation of a blade and its operating system. The organization structure goes hand in hand with the role-based access control and delegated management features. The RBAC features not only allow fine-grained privileges to be assigned to different management users, but also allow restriction of a user's privileges to a specific set of organizations. You assign alternate roles in vSphere, but right now only administrator at vSphere.local is supported on VXRail. Secure separation refers to the effective segmentation and isolation of tenants and their assets within the multi-tenant environment. Service assurance provides consistent, enforceable, and reliable service levels. Unlike physical resources, virtual resources are highly scalable and easy to allocate and reallocate on demand. In multi-tenant environments, the service provider prioritizes resources to meet the needs of tenants based on service level agreements. Security and compliance ensures the confidentiality, integrity, and availability of each tenant's environment at every layer of the TMT stack using technologies like identity management and access control, encryption, and key management. Availability and data protection ensures resources and data are available for use by the tenant. High availability makes certain resources are always online and available when needed. Data protection is tasked with ensuring that important data is safe against data loss as well as knowing where the data is located. Tenant management and control refers to the service provider delegating a portion of administration or control to the individual tenant. Tenants should have control over relevant portions of their service, such as provisioning allocated resources, viewing change management status, managing administrative contracts, etc. Service provider management deals with comprehensive control and compliance visibility into the shared infrastructure in order to meet SLAs. While the VXRail appliance has a number of security benefits, it also has some challenges associated with it. As with any consolidation technologies, the risk of a security breach occurring is magnified as multiple virtual systems are housed on a single physical system, and having all of those disparate systems coexisting on a single piece of hardware complicates the environment significantly. Workload mobility causes challenges with traditional security mechanisms, as physical mechanisms are often tied to physical resources and do not adapt to virtual computing environments. In addition, compliance requirements may be challenging due to the variability of where the service may reside. A centralized management solution certainly simplifies the administration of a complex environment. However, if not secured properly, it can also become an easy target to get access to the entire environment. In addition, a breach within a single tenant's environment in a multi-tenant configuration can cause a ripple effect and allow the breach to spread throughout the environment. Finally, while the infrastructure is a secure environment, it will need to be connected to an external network to provide services external to the VXRail appliance. And if that network is not secured, it can expose the VXRail appliance to exploits that it would normally not encounter. Because VXRail appliance infrastructures are a grouping of existing technologies, the security controls are understood and known, and because the components are deployed in a consistent manner each time, the security controls can also be applied in the same methods. The virtualized infrastructure allows for security mechanisms to be inserted into the stack, making it an integral part of the solution and not an afterthought. The consolidated management allows for a more comprehensive security model. Additional security mechanisms can be added to the solution if desired. To read more about vSphere security for ESX 6.0 and vCenter Server 6.0, access the vSphere security at the provided links. VMware Security Hardening Guides provide prescriptive guidance for customers on how to deploy and operate VMware products in a secure manner. Guides for vSphere are provided in an easy-to-consume spreadsheet format with rich metadata to allow for guideline classification and risk assessment. They also include script examples for enabling security automation. Comparison documents are provided that list changes and guidance in successive versions of the guide. See more at the included link. Using VLANs to segregate data is a very powerful security mechanism. It allows granular control of which systems have access to different application or types of data. Multiple VLANs may be set up to segment traffic by application, types of data, I/O profile, or group. Notice in the example, this environment, as seen in the virtual distributed switch, shows many VLANs with meaningful names. Assign useful names, as this could assist in debugging or monitoring the environment. The VXRail appliance is just like any other piece of technology, is only as secure as the protocols that are used to access it. Using unsecure protocols provides a vehicle for attackers to gain access to sensitive information. Using secure protocols prevents an unauthorized person from using any information that they may gain access. Similarly, disabling unused services and keeping the system's internal firewall hardened reduces the vulnerability of a system. The compliance management process is not unlike the RCM compliance process we described. The compliance scans automate the key phases required to maintain security policies. The Converge shell, also in VCE Vision release, lets you automate the process of resetting policies based on the results of the scan. The Converge shell is available as core VCE Vision technology, and users can create custom shell extensions for automating functionality. VCE recognized the benefit of automating a number of security hardening remediation operations that commonly occur after a failed compliance scan. The security hardening module is a predefined shell extension pack available optionally, and it automates the reconfiguration process for security settings across multiple systems in the data center. Vision intelligence and automation enables a standard, more efficient, and continuous process for keeping infrastructure in the best security hardened posture. Here's an example of the Vision workflow. In the top left screen, every component in every VCE system comes from the factory with a default security settings based on component vendors and industry best practices. The settings are documented in the VCE System Security Guide shown here. In the top right screen, Vision audits system-wide compliance with the policies or default settings in the guide and provide a security score per system. This is weighted score 0 to 100. The higher the number, the greater the compliance. Vision lets you tailor policies as well as create fully custom policies for Vision to audit. Bottom of the screen, a report provides a compliance score and overall score per type of component: compute, network, storage, or hypervisor. The report also gives you details about security settings that are out of compliance, so you can take action to harden their settings. Top left screen, you can set up Vision to continuously audit for compliance to help you sustain the best security posture. The Vision shell is an interface that enables you to automate changes in settings and corrective actions to enforce compliance across multiple components in VCE systems. Our customers say this speeds response to vulnerabilities and sustains the best security posture with less manual labor. Vision intelligence and automation enables a standard, more efficient, and continuous process for keeping infrastructure in the best security hardened posture against newly found security holes in multi-vendor technology components. Vision can now perform security scans to determine their VSA VTA posture across the whole data center. VSA is VCE Security Alerts and VTA is VCE Technical Alerts. This extends the compliance platform in Vision and provides the customer with a fast, safe, and reliable method for keeping the system secured and stable. Here's an example of the Vision workflow. In the top left screen, VCE emails you security alerts or VSAs. These are consolidated alerts from component manufacturers about vulnerabilities that they have discovered. Top right screen, Vision audits systems to pinpoint vulnerabilities and provide a security score per system. This is a weighted score 0 to 100. The higher the number, the less security vulnerability. In the bottom right screen, a report provides details of impacted systems and components. in the bottom left screens, we mitigate risk by downloading and applying security patches for VCE systems multi-vendor components from the VCE support website or by following VCE knowledge article guidance. In the middle left screen, automate continuous auditing for compliance to the VCE security guide, which contains best practice for hardening components and their settings, and or custom policies to meet your own best practices. Our customers say this speeds response to vulnerabilities and sustains the best security posture with less manual labor. Security is a multi-layer challenge for both the physical and logical with its layers of virtualization. Vision intelligence and automation enables a standard, more efficient, and continuous process for keeping infrastructure in the best security hardened posture. Security is an ongoing practice that must be implemented, monitored, and adjusted over time. Welcome to VCE VXRail Appliance Resource Management. Upon completion of this module, you should be able to understand how to manage VXRail system physical resources, understand the steps to add a new VLAN and why you may want to do this, and describe how Log Insight can provide a quantitative analysis of the VXRail over time. VCE VXRail Appliance is architected with VCE branded servers, VMware virtualization, VMware operations, and VCE managed software. The virtualized environment is based on physical nodes, network interface card, memory, and disk storage. The software stack of VMware and VXRail come together to deliver a consolidated solution using software-defined storage, making up the virtual SAN for the VCE VXRail appliance. It is easy to add another appliance, providing more resources for the ever-growing and changing IT environment. Let's look at some physical attributes of this environment. The VXRail appliance server specifications include a chassis with 1 to 4 nodes each, self-contained with dual processors and a minimum of 128 gigabytes of memory. That's for a smaller configuration. Larger configuration options are available, but each node in the appliance should have the same amount of memory resources. Each node also has up to 6 physical disk drives, 1 solid-state disk, which is in the first drive slot for a node, and 3 to 5 hard disk drives. Before expansion of a VXRail cluster, you must first fill up all 4 node compute slots in the first appliance before single addition node compute can occur. Each individual node also has 2 10 gigabit network ports and a 100 megabit BMC port. They also include their own USB ports, VGA, and serial ports. In dual top-of-rack switch deployment, high availability is provided at the ESXi node level, the top-of-rack switch uplink level, and the top-of-rack switch level. This is the recommended top-of-rack switch topology deployment for high availability. The switches and network environment need to be understood and kept up to date. If a new VLAN is added to VXRail, it must also be added to the switch. This will be discussed later in this course. As you know, vSphere is extremely powerful, and we have at our fingertips detailed information about the physical as well as logical environment for virtualized infrastructure. It is managed by VMware vCenter Server 6.0. The VMware vCenter server provides the management of vSphere deployments and the rapid provisioning, monitoring, and controlling of virtual machines. In VXRail deployments, all the ESXi nodes in the appliances and the Virtual SAN data store are backed by a single instance of the VMware vCenter server. The VMware vCenter server framework is installed as a single virtual machine configuration on the primary node. You now also have the option to connect to an existing external vCenter environment. VXRail Manager automates the provisioning of hosts and monitors the virtual infrastructure. The initial VXRail Health page presents a view of the overall system health, which displays the storage IOPS CPU memory usage of the overall cluster. There are also links at the top of the display that will provide detailed health information of each individual appliance in the cluster. The Physical tab of the VXRail Manager provides the physical view of the hardware. From the main dashboard, select Health option in the left navigation pane. Then along the top, select Physical. This page will display detailed information about the cluster's appliances. Clicking on the magnifying glass beside each appliance will present hardware details of that particular appliance. Within the detailed view of a particular appliance, each can be selected to display physical details of that component. Also, this would be the place you start a crew-through hardware replacement. By selecting an individual node, you can see more information. You can see BIOS, SATA DOM, and NIC information. Notice also the wrench by the node information. Now let's watch a short video on exploring VXRail Manager.
This demonstration explores the VXRail Manager 3.5 console. Open up a web browser and log into the VXRail Manager console. First screen shown is the dashboard, which has the overall system health, VXRail community, support, and event history. Clicking on the VXRail community will open up another browser tab where you can get information about the VXRail appliance. Clicking on the support button or selecting the support tab will bring you to this screen. Here you have the latest information on the latest heartbeat. You can also chat with support, open up a service request, and view the last configuration sent. Here you can also do some searches with the knowledge base. Click on Chat with Support. Another browser web tab will open up. If not already logged into the EMC account support, you may do so here. You can also click on VXRail Community and select the prior screen, which will open up a tab on the browser, where here you can look at the overall content and other events with the VXRail appliance. Lastly, clicking on the knowledge base will also bring up a new browser tab. Here you can look at different articles, downloads, marketplace, and other advisories listed for the product. Clicking on the event page will bring up the system events. Here you can select an individual unit and then look at the event details on the far right-hand side. Next we'll select the health tag. Here you have two views, logical and physical. With the logical, you can look at the overall health with a timeline as well. You can look at individual components such as hard drive, networking, and other individual hardware components. Next, we'll take a look at the physical tab, which will show us individual hardware components. If you had more than one appliance, multiple listings would show up. If you select on any individual item, the disk information or other items will show up for that particular one. If you need to do any replacement of a failed unit, there you can select the hardware replacement feature. Lastly, we'll select the configuration tab, which has three options: features, market, and general. Within the features, you can look at what individual applications are listed here. Under the marketplace, we can look at the different ones that are available for download that comes prepackaged with the VXRail appliance. Under the general tab, there's many different things to select. Here you can select the EMC support account. Here you can enable EMC's secure remote ESRS. We can also look at the configuration network environment settings, suppress cluster monitoring. Here we can run a system diagnostics, which will check the health of the system at that current moment. We can also perform a system shutdown of the cluster. And lastly, we can select the default language used for the display. This concludes the video.
If you scroll down the page in VXRail Manager Health tab, it reports on each ESXi node. Some of the details you can see are the HDD, STD, and ESXi disk status, along with the NICs and their send-receive rates. The numbers reported here are pulled every few seconds from the Performance API of vCenter, and the data represents the live measurement at that point in time. Each ESXi node uses one virtual distributed switch that contains multiple port groups, and the VDS spans across all nodes. A port group is an aggregate of multiple ports with a common configuration. Each port group is identified with a network label. In VXRail, traffic can be tagged at the port group level. In this example, VLAN ID 270 is used on the management network, vCenter server network, and Marvin management network port groups. VLAN ID 30 is used for a vSAN port group, and VLAN ID 20 is used for vSphere vMotion port group. At the top of rack switch side, the switch port that is connected to the ESXi node must be configured to accept the tagged traffic. This will only occur if the port is configured to be in trunk mode and configured to allow the VLAN traffic to pass through. If this is true, the switch will accept the tagged packets, strip off the VLAN tags, and forward the packets to their destination. Besides viewing the NIC from VXRail, you can also view it in vSphere. From the vSphere web client, navigate to Host and Cluster, then select the network and physical adapter. Here you can see the MAC address for the physical adapter. As new virtual machines are created in a VxRail environment, it may be necessary to add more VLANs to separate network traffic. You may want to do this to have separate groups for different applications, additional separation for security reasons, or different characteristics of the network traffic itself. This can be done by navigating from the home icon in vSphere to Networking, selecting the VxRail distributed switch, distributed port group, etc. For more information on VMware and its functions, please see the VMware vSphere 6.0 documentation at the following link. Once the new VLAN is added, you will see it as a network pick option when creating a virtual machine, as shown in this example. Note there are some networks you do not want to choose for virtual machine traffic, such as the management networks. Make sure you know which networks are for virtual machines in your environment, and also make sure that the new VLAN information is set up on the VxRail network switches. You will most likely have to have a network administrator execute a switch update to get a new VLAN in place. Again, you can look high level at the logical devices that make up a virtual machine, but they are backed by real devices with specific attributes. This view shows network interface card in its speed, MAC address, etc. By navigating to hosts, manage networking, then physical adapters, you can see the detail for each host and its devices. In this case, we're looking at the physical network interface cards, which show us 2 ports. We also saw 2 NICs in VxRail. After the installation of VxRail is completed, the Log Insight virtual machine can be seen in VMware vSphere's list of virtual machines. The Log Insight VM can be managed with a browser by logging on at the IP address set for the Log Insight during the VxRail installation. The default username for Log Insight is admin, with the password set for vCenter during the VxRail installation. VxRail VM Log Insight VM provides organized access to data in many forms. You can create dashboards and even use interactive analysis. It can report on many aspects of the VxRail environment, from physical infrastructure down at the SCSI level or logical entities such as virtual machines. vRealize Log Insight can show data for many different scenarios. Here we are looking at the storage, SCSI, latency, errors screen. You can see that there was an issue and then it was resolved, as no more blue bars are seen after a certain point. The first graph are errors by device and the second are error by hostname. You can also drive down into more detail if needed. For instance, if the same device is having issues across multiple hosts, then it's most likely a device issue, and that's how you can start an analysis. In summary, we reviewed the key aspects of the physical VxRail appliance. We learned how to look at more detail of the physical environment. We discussed why one would add a new VLAN and some of the considerations. We explained how Log Insight can access VxRail running information to provide analysis over time. Welcome to VCE VXRail Appliance Virtualization Management. The objectives of this module are to understand the deployment of options for virtual machines, be able to discuss monitoring the VCE VXRail virtualized environment, its capacities and performance, and understand how to migrate a virtual machine and any prerequisites for this process. The VXRail appliance is 100% VMware virtual infrastructure and is installed ready to deploy virtual machines. This simplifies placement of virtual resources but does not take away from the tasks of capacity planning nor lifecycle management of a virtual environment. The VXRail appliance operational environment is 100% VMware virtualized infrastructure. Nodes all run ESXi hypervisor. Host servers run operating systems on virtual machines that are built on virtual CPUs, virtual memory, and have connectivity provided by vSphere distributed network switch and segregated by virtual LANs or VLANs. VXRail appliance virtual resources are created, provisioned, and managed the same as other VMware virtual environments. We talked about hardware, but all hardware that we physically see, we can logically see in vSphere Web Client and VXRail. Whether it's a compute node, NIC, or disk, we can get information about all of them. At the lowest layers with BMC and the remote management module support, or looking at VXRail physical presentation via VXRail Manager, we can get all the details and more, but this is why VXRail Manager is so great, as we can see the high-level representation of the appliance in VXRail Manager and get alerted if there is an issue going on. We don't have to pore over voluminous amounts of information all the time because VXRail does it for us. However, there may still be times when we need detail. It's good to know we have the details if they're ever needed using the vSphere environment. In this slide, using the vSphere Web Client interface, we navigated from the Home icon, chose a VXRail node in the left navigation pane, then Summary in the right pane. This gives you some high-level information about the node. You can get more details by going into the Monitor, Manage, or Related Objects tab. You can manage the ESXi host from the vSphere Web Client. If you navigate in the left pane selecting a host, then right-click, you will be presented a list of functions. From this pick list, you can control power on, power off for a single host, put the node into maintenance mode. This would only be needed if support directed you to do so. Before a host will go into maintenance mode, all VMs must be powered down or moved off the host. Storage will give you access to see what storage this host has access to. This is useful in particular to look at the host's data store, which is one of the host's SATA DOM drives. You can also export system logs for a selected host. Next, we look at the physical disk storage. From the Home icon in the vCenter Web Client, navigate to Storage, Related Objects, and Data Stores. Here you will see a list of the data stores in the data center. Notice there are 4 EMC type data store with type VMFS5, and the last entry data store is vSAN. There are many ways to look at the environment, and exploring these are very informative, but don't forget that VXRail makes running, monitoring, scale-out, and upgrading very easy. For each data store, you can gather more information about it for each ESXi host by navigating to Manage, Settings, to see high-level information. You can also choose device backing to get even more detail about the physical environment and the underlying devices. A vSAN data store is created using the storage provided from each ESXi node. The vSAN data store size will be an aggregate of all the SAS drives in the clusters. SSDs are not used in calculating the size of the data store. For example, if there are 8 hosts in the cluster and each host contributes 3 SAS drives that are 12 gig in size, the vSAN data store will be approximately 288 gigabytes. All VMs created in VXRail are automatically added to the vSAN data store. These VMs include the system VMs as well as the customer deployed VMs. The vSAN manages objects. Virtual machine files are called objects, and there are 4 different types of VM objects: VM home files, VM swap files, VMDKs, and snapshots. Continuing on in storage, you can also review the virtual SAN, looking in Manage, Settings, General, then seeing the capacity and free space. In order to see files in the virtual SAN, select Manage, then Files. From the home icon in vSphere Web Client, navigate to Storage, Manage, Device Backing, and you will be able to see the physical disks that make up the virtual SAN. These disks are from the ESXi nodes. The top portion of this screen shows each node and the disk group. Notice that the disk group for both nodes are the same. They should be, as it's the VXRail virtual SAN. On the bottom screen, it shows you the physical disks that each node has contributed to the software-defined storage virtual SAN for the VXRail environment. Still staying in storage, now select Related Objects and Virtual Machines. You can see each virtual machine that is using storage and the virtual SAN and how much each are allocated. This is useful to see if any one VM is using too much storage, or also when retiring servers and seeing how much storage you could reclaim when you delete a virtual machine. The vSAN cluster configuration by default is configured to automatic. This means that all empty local disks on each ESXi node will be used to create the shared data store. This shows all the resources used in the vSAN for the cluster. In vSphere 6.0, VMware requires a vSAN cluster to have at least 3 ESXi nodes. VCE strongly recommends a minimum of 4. At least one disk group that contains at least one SSD and 3 HDD. Here are the basic vSAN requirements. By default, VXRail has 4 ESXi nodes for each appliance, one disk group in each ESXi node that contains one SSD and 3 HDDs. The Marvin storage profile policy is created during installation. This policy uses rules based on vSAN and is able to survive the failure of one node or disk group. By default, the storage policy is applied to the vSAN data store, which is the data store created during installation. This is the name and description for the default Marvin storage policy. This is the rule set for the policy. Notice that the rule set specifies that the rule will tolerate one failure. This shows that the rule has been applied to the Marvin data store. You can create an ISO directory in the vSAN data store that can be used during the VM creation process to find ISO files that you have already uploaded to this directory. You can see the ISOs stored on the vSAN data store in the ISO folder by browsing the data store in vSphere. These ISOs take space, so at minimum do a once a year spring cleaning and make sure you're only storing the ISO files that are needed. vSphere DRS, or Distributed Resource Scheduler, is configured to be fully automated by default. It is also important to note that in the current release, vSAN Distributed Power Management is disabled. Enabling it would create issues for vSAN and patch management. Therefore, DRS is fully automated on all nodes at all times. This is true even with 8 appliances, 32 nodes. HA is also enabled by default. As the VXRail appliance enters production, the virtual infrastructure must be monitored and administered. Managing virtual resources can be done in the same manner as the other VMware virtual infrastructure environments. Customized capacity for a virtual machine can be done using vCenter. This can be related to storage space, virtual CPU and memory, load balancing, and network requirements. In the left navigation pane, if you select a VM, there are many options to control it in its environment. To see all the options, select the VM and right-click to see what is available for this particular virtual machine. Besides being able to power on/off a VM, you can create a snapshot, clone, create a template, add or remove devices via Edit Settings. VMware provides multiple methods for building virtual machines in vSphere. Some of these methods, such as cloning or deploying VMs from template, require vCenter. Others are universal to whatever management platform is being used. Some of the most common methods of VM deployment are building a virtual machine. Building a VM from the ground up involves building the VM, installing a guest OS into the VM, and installing the VMware tools. Installing an OS into a VM takes about the same amount of time it would on a physical system. Many of the deployment methods outlined below involve imaging a base VM and avoid the need to perform the OS install each time. Cloning a VM. Cloning VMs involve taking a copy of a base VM, an image, in order to create a new virtual machine. At a very basic level, cloning takes a copy of the configuration and the storage files for a virtual machine and uses the copy as the basis for a new virtual machine. Deploying a VM from a template. Deploying a virtual machine from a template involves building a template off of a base image virtual machine and then using the static template to provision new virtual machines. Templates consist of the same files that support a virtual machine, so deploying a VM from template essentially involves copying these files to create a new VM. Importing a virtual appliance. For a VM to be imported as a virtual appliance, it has to be prepared in Open Virtualization Format, or OVF, prior to import. Once imported, the virtual appliance can just be started in the ESXi or vCenter inventory. Cloning is a method of deploying a virtual machine that involves imaging a base virtual machine to produce a clone copy. The source virtual machine can be in a powered on state or in a powered off state when the cloning operation is initiated. At the platform level, cloning involves copying the configuration and storage files that support the source VM to produce a copy a new VM that has the same configuration and data as the source. Once a new clone VM has been generated, the guest OS can be customized to assign a new identity, IP configuration, etc. to the clone guest. The ability to clone new VMs from an existing image demonstrates one of the key benefits of virtualization: the ability to easily provision new VMs from a source image, taking advantage of the fact a VM is represented as a collection of files and its OS and application data are encapsulated. Templates are a method of deploying a virtual machine that involves creating a master template from a base image virtual machine and then using the template to generate multiple virtual machines. Templates consist of the same configuration state and storage files that support a standard virtual machine with slightly different file extensions. A template is really a virtual machine that is flagged as a static template that cannot be powered on. Once a template has been created, multiple VMs can be generated from the template. Deploying a virtual machine from the vCenter template initiates a set of operations that copy the template files to produce a new virtual machine. Each deployed virtual machine will have the same configuration and storage data as the source template. To grant each virtual machine a unique identity, IP configuration, and other unique properties, the guest OS must be customized manually or through automation. There are two methods for creating templates in vCenter: convert to template. Convert to template converts an active virtual machine into a template and it is a simple status change to the virtual machine. A VM can be converted from a VM to a template and vice versa, facilitating easy updates to the template image for OS service packs and patches, etc. Clone to a template. A clone to template operation leaves the original base image VM intact and clones a new template off that image. The ability to create a template and deploy new virtual machines from the template demonstrates one of the key benefits of virtualization: the capability to easily provision new VMs from a source image, taking advantage of the fact that a virtual machine is an encapsulated set of files. When a new virtual machine is deployed from a template or through cloning, the newly deployed VM is an exact replica of the source VM down to the system identity, hostname, IP information, IP address, registry data for Windows guest, security identifiers, SID, and license configuration. To ensure that each new VM has a unique network security and software identity, guest OS customization is performed. Guest OS customization can be conducted manually or through automation, but basically involves editing those parts of the guest OS configuration that should be unique for each virtual machine. Without the benefit of guest customization, every newly deployed virtual machine would have the same hostname, network SID, and license identity, resulting in network and system conflicts. Guest customization avoids this situation by leveraging tools that are native to the guest OS to perform customization of the VM's underlying identity information. vCenter supports the ability to call guest customization tools, such as Microsoft SysPrep, through a vCenter wizard interface outside of the guest, so that deployment and customization can be handled as one automated operation. A guest customization specification can be in in XML format so that the same spec can be used to customize multiple guests. Virtual machine snapshots enable the preservation of a virtual machine state at a specific point in time, so it can be repeatedly returned to the same state. Snapshots can be taken while a VM is powered on, off, or suspended. It captures the state of the memory, system settings, and disk. A snapshot is a copy of the virtual machine's disk file, VMDK, at a given point in time. Snapshots provide a change log for the virtual disk and are used to restore a virtual machine to that point in time. A snapshot may be used if you are going to apply maintenance or make changes to a virtual machine. You would first take a snapshot prior to any changes, make the changes, and then if needed, you could easily restore the virtual machine back to its original state at the point in time of the snapshot. A snapshot is seen more like a temporary copy and generally shouldn't be kept longer than 24 to 72 hours, as the snapshot is based off of and tied to the original or parent disk. For more information about VMware snapshots and other functions, please see the VMware vSphere 6.0 Documentation Center. With supported guest operating systems, you can also add CPU and memory while the virtual machine is powered on. After selecting the virtual machine and right-click on it, we see the Edit Settings options. You can add or configure most virtual machine properties during the virtual machine creation process or after you create the virtual machine and install the guest operating system. If you click the Select button at the bottom of the Edit Settings screen, you have more options to add or remove devices. You can configure the virtual machine hardware and can change nearly every characteristic that you selected when you created the virtual machine. You can view the existing hardware configuration and add or remove hardware. You can configure CPUs, CPU hyperthreading, resources, memories, and disks. Not all hardware devices are available to every virtual machine. The host that the virtual machine runs on and the guest operating system must support devices that you add or configurations that you make. You can dynamically increase the virtual disk size on a virtual machine. Navigate to the VM and select Edit Settings. Some prerequisites for this operation are making sure that the virtual disk is in persistent mode. It must not have any snapshots associated to it, and the process must be supported by the operating system. Continuing on in Edit Settings of a virtual machine, this is the second way to add storage to a virtual machine. One can add new disk storage to a VM by selecting the new hard disk, then specifying the size of the new disk. Notice it defaults to the VXRail vSAN and also has 2 copies that are created. This is because the number of failures to tolerate is set to 1, or N. This means for N failures tolerated, N plus 1 copies of the data are created. 1 is the default for VXRail. If creating a virtual machine and the vSphere web client that will be used in the VXRail environment, ensure you select the VXRail vSAN storage and not the individual data stores. This is asked when using the new virtual machine wizard in the vSphere web client. Note, if using the vSphere client app, it could choose any data store, so you must be careful and make sure you choose the virtual SAN data store. Migration means moving a virtual machine from one host to another. There are 3 types of migration. Cold, migrate a virtual machine that is powered off. Suspended, migrate a virtual machine that is suspended, and vSphere motion, migrate a virtual machine that is powered on. 128 concurrent migrations are possible to the same VMware vSphere data store. Enhance vMotion Compatibility, EVC, is a cluster feature that prevents vMotion migrations from failing because of incompatible CPUs. EVC ensures that all hosts in a cluster present the same CPU feature set to virtual machines, even if the actual CPUs on the physical hosts are different. It prevents migration failures due to CPU incompatibility. A vSphere vMotion migration moves a powered-on virtual machine from one host to another. It provides these capabilities: improves overall hardware use, continuous virtual machine operation for scheduled downtime, VMware vSphere DRS balancing VM across hosts. Before a virtual machine can utilize vMotion, it must meet the following requirements. It must not have a connection to an internal standard switch, virtual switch with its 0 uplink adapters. It must not have CPU affinity configured. vSphere vMotion must be able to create a swap file accessible to the destination host before migration can begin. There's a wizard to guide you through the migration process, making it very easy. The vSphere Statistics subsystem collects data on the resource usage of inventory objects. Data on a wide range of metrics is collected at frequent intervals, processed and archived in the vCenter server database. You can access statistical information through command line monitoring utilities or by viewing performance charts in the vSphere client and the vSphere web client. On vCenter server, managing your hosts, you can review information on CPU utilization on virtual machines that are available in vCenter server. Temporary spikes in CPU usage indicate that you are making the best use of CPU resources. Consistently high CPU usage might indicate a problem. You can use the vSphere client CPU performance charts to monitor CPU usage for hosts, clusters, resource pools, virtual machines, and vApps. As the VXRail appliance enters production, the virtual infrastructure must be monitored and administered. Managing virtual resources can be done in the same manner as other VMware virtual infrastructure environments. Host machine memory is the hardware backing for guest virtual machine memory and guest physical memory. Host machine memory must be at least slightly larger than the combined active memory of a virtual machine on the host. A virtual machine's memory size must be slightly larger than the average guest memory usage. Increasing the virtual machine memory size results in more overhead memory usage. The data store is at full capacity when the used space is equal to the capacity. Allocated space can be larger than the data store capacity. For example, when you have snapshots and thin provisioned disks. Consider consolidating snapshots to the virtual disks when they are no longer needed. Consolidating the snapshots deletes the redo log files and removes the snapshots from the vSphere client and vSphere web client user interfaces. Use the disk charts to monitor average disk loads and to determine trends in disk usage. For example, you might notice a performance degradation with applications that frequently read from and write to the hard disk. If you see a spike in the number of disk read-write requests, check if any such applications were running at that time. Network performance is dependent on application workload and network configuration. Dropped network packets indicate a bottleneck in the network. Slow network performance can be a sign of load balancing problems. In summary, we've reviewed deployment options for virtual machines using clone and templates. We've discussed the use of snapshots in that generally you don't want to leave them there for longer than 72 hours. We've discussed how you can monitor resources and performance. There are many options using VXRail in VMware vSphere environment to monitor and manage your VXRail environment. Welcome to the VCE VXRail Appliance Data Protection Administration. This module are to discuss considerations for backup and recovery related to business continuity. We will review products offered by the Market tab in VXRail, reviewing Cloud Array, Recover Point for VMs, and vSphere data protection. You should also understand how a virtual machine snapshot and clone can assist in data protection. VCE provides solutions to meet all VXRail appliance data protection requirements. The focus is on integrating industry-leading technologies into a strategic platform offered by VCE to simplify data protection. Enterprise backups are outdated and need to evolve to keep pace with the latest advancements in Cloud Array infrastructure. The backup process has changed very little. There have been improvements along the way with the speed and capabilities, but it's the fundamental way we back up that has not evolved with the way IT is run in the data centers. With no visibility or control of backups, each team rolls its own solution. VXRail integrates VMware and EMC backup and recovery technologies, creating solutions to have more frequent backups with reduced backup windows. With data protection, there are different levels of requirements. Some may need a very stringent recover point objective, and others may need continuous uptime with no downtime. To start with the basics, all data should have some kind of daily backup, even if it's only change data. With this approach, a daily backup can provide a business with a maximum loss of 24 hours worth of lost data. Moving up the stack, other applications may need special interim snapshots of the data. This is where local replications and snapshots can come in. Becoming more stringent could be a continuous point-in-time snapshot at very tight intervals. This is where Recover Point can come in. Finally, for those that require no downtime, vMotion can be used to move virtual machines to another location for continuous availability. Note, none of these solutions are fault tolerant, but rather fault resilient. It is very important to understand the recovery time objective and recovery point objective for each different application and its environment. Today's businesses need to keep a backup copy of their local data on site to follow industry regulations or to ensure business continuity. Some organizations also need to replicate their local servers and applications to external locations to guarantee minimal recovery time objectives in case of a disaster. Whichever is needed, deploying a VXRail appliance is the perfect time to transform backups and disaster recovery. Data protection these days is not just a backup of data, as rapid data restoration is essential to fast-paced business environments. The first layer of protection should be where the data lives on disk. This can be accomplished with keeping multiple copies on disk. VXRail does this with its use of the virtual SAN in its storage policies. The next layer of protection is using snapshot or clones to make an immediate backup copy. This would be used to take an immediate copy prior to applying any updates to a virtual machine and its environment. The next layer of protection are local backups, using VMware vSphere data protection and or recover point for VMs, both protecting against physical and logical failures. We will be looking at both of these options in this module. 4 nodes have advantages over 3-node clusters. Customers are often surprised by limitations of using a 3-node solution. 4-node solutions provide full protection when a node is lost, as the virtual SAN can then tolerate another failure. Another use is during rolling upgrades, where a 4-node cluster would give you full data migration and protection during the upgrade. If you want VMs to remain highly available during a failure, maintenance or upgrades, buffered capacity and a minimum of 4 nodes are needed by vSAN. Checksum is enabled as a cluster-wide setting. It can be disabled on a per-object basis using storage policies. Software checksum will enable customers to detect the corruptions that could be caused by hardware, software components, including memory, drives, etc., during their read or write operations. In the case of drives, there are 2 basic kinds of corruption. The first is latent sector errors, which are typically the result of a physical disk drive malfunction. The other type is silent corruption, which can happen without warning. Undetected or completely silent errors could lead to lost or inaccurate data and significant downtime. There is no effective means of detection without end-to-end integrity checking. During the read-write operations, vSAN will check for the validity of the data based on checksum. If the data is not valid, then it should take the necessary steps to either correct the data or report it to the user to take action. These actions could be fetch the data from another copy of the data for RAID 1, 5, or 6. This is what we call recoverable data. If there is no valid copy of the data, the error shall be returned. This is what we call non-recoverable errors. The number of failures to tolerate policy setting is an availability capability that can be applied to all virtual machines or individual VMDKs. For VXRail Virtual SAN, the number of failures to tolerate is set to 1. This means there are 2 replica mirror copies of the virtual machine or individual VMDKs across the cluster. If the number is set to 2, 3 mirror copies are created. If the number is set to 3, 4 copies are created. You need to consider the number of replica copies when sizing storage resources. Organizations are now required to keep information applications online 7 days a week, 24 hours a day, 365 days a year. When there is an outage or a disruption, service time to recovery has a real cost to the business. In the event of a catastrophic failure, Data loss can not only have an impact to the business operations, but to the organization's very existence. Having secondary copies is a necessity. Maintaining a consistent, restartable copy of production applications is part of normal business practices. Recovery point objective is how much data a company can afford to lose in the event of an outage or disaster. Recovery time objective, or RTO, is how long a company can be without access to applications and data. Both of these need to be considered very carefully. Although we'd all like to never lose data and never have any downtime, there are real business costs to achieve this. One has to weigh the pros and cons and find a good balance between RTO and RPO for each application environment and its data. VMware vSphere Data Protection is a backup management, recovery, and replication utility for virtual machines and applications that are based on EMC Avamar deduplication technology. VDP is a Linux-based virtual appliance for backup and recovery that is included as part of the VXRail solution. VDP can perform agentless image backup, replication, and restore, individual disk backup, variable length dedupe, change block tracking restore, and file level recovery. Powered by EMC Avamar, vSphere Data Protection provides disk-based backup and recovery via simple wizards. VDP backups can be stored on EMC data domain systems. Included with VXRail is vSphere Data Protection, which is deployed as a virtual appliance on the VXRail system. It provides up to 8 terabytes of backup capacity. VDP features built-in deduplication for rapid backups and reduced network bandwidth when replicating to EMC data domain systems. This deduplication also reduces the backup window by 90% and significantly reduces the required capacity for backup storage. If restoration is needed, VDP features a one-step recovery process that is highly efficient, secure, and fast. EMC Recover Point for virtual machines is a business continuity solution that is incredibly simple to use, yet gives you peace of mind by protecting your virtual machines at a granular level. Recover Point for VMs will protect the virtual machines deployed on VXRail by providing continuous data protection. The software has built-in orchestration and automation to streamline your protection schemes. With Recover Point for virtual machines protecting VXRail appliance resources, administrators can easily replicate data to and from remote offices in the event of a disaster, ensuring that the business suffers no downtime. VMs can be rolled back to a known good point in time and resume operations quickly and efficiently. Recover Point for VMs is closely integrated with VMware vSphere so that management can be done from within vSphere's management interface. Recover Point splitters for ESXi reside on all servers with protected workloads, allowing replication and recovery at the virtual disk granularity level. Since the I/O splitter resides within the vSphere hypervisor, Recover Point for VMs can replicate virtual machines to and from any storage array supported by VMware, including SAN, NAS, DAS, and vSAN. Recover Point architecture uses an advanced journaling system to track changes. This allows for replication across a WAN and extremely granular recovery point options. After being deployed from the VXRail market, provisioning of replication tasks can be performed with a simple wizard from vSphere Web Client. Administrators can conduct automated disaster recovery tasks from within the Recover Point for VM's vCenter plugin. Standard VXRail licensing includes a 15 VM license for Recover Point for virtual machines. To install Recover Point for VMs, first download the manual from support.emc.com. You want to get the guide Recover Point for Virtual Machines Installation and Deployment Guide, and then follow the procedures within the guide. As part of VXRail's value-added package, EMC Cloud Array software provides scalable, cloud-based storage with your choice of many leading cloud providers, enabling limitless network-attached storage, off-site backup and recovery, and the ability to support both iSCSI block service as well as NFS and CIFS file services. Cloud Array provides a sophisticated bandwidth scheduler and data reduction technology that minimizes network impact and keeps your VXRail appliance running optimally. EMC Cloud Array also enables organizations to extend their SAN and NAS with on-demand cloud storage, providing a permanent solution for block and file capacity expansion, off-site storage, and data archiving. Each VXRail appliance is being offered with 1 terabyte of local cache and up to 10 terabytes of cloud-based storage, extending VXRail to the cloud. Additional licenses are available to expand as needed. Shown here is a simple diagram of Cloud Array's architecture. As users and applications access data on Cloud Array, they write and read against Cloud Array's cache. The data is then reduced in size, encrypted, and stored on private or public cloud storage. In summary, we've discussed some considerations for business continuity, backup, and recovery. You've learned it's important to understand the RTO and RPO for the application environment being backed up, knowing that there are trade-offs that must be decided. One has to also consider how much data, growth rate, and how backups could affect performance in the environment. We explained the VXRail options to address business continuity, looking at Cloud Array, Recover Point for VMs, and vSphere data protection. Welcome to the VCE VXRail Appliance System Maintenance. The objectives of this module are to describe the basic processes and procedures for VXRail system maintenance, explain the process for performing VXRail system checks, be able to identify a failed component and describe the customer replacement process, and understand the overall scale-out process. For VXRail Appliance, all system maintenance is handled working with EMC support. It is a NDU, non-disruptive process. The software updates are bundled together or may just contain updates for one component of the VXRail appliance. Either way, this is the only way maintenance is to be applied to this environment. You should not apply an individual fix to any part of the environment, including VMware, unless instructed to do so by EMC support. The goal of any system maintenance is to improve the environment, whether protecting it from potential issues or securing the environment. System maintenance should be a planned event. There are several items to understand when planning maintenance. Understanding the environment helps one to set and manage expectations. Here are some of the considerations. Understand the users. Are they 7 by 24? Do they have any critical time periods? Do they have any strict SLAs in the environment? Are there times when all systems must be up instead of having one down in an NDU process? You should also ask them if they have any specific backups. You know that you will be taking backups, but do they have any specific ones? Also, you want to review the system maintenance objectives with EMC support. You want to verify the environment is in the proper state prior to maintenance application. Backups are always strongly recommended before any system maintenance, but also knowing the environment helps with an uneventful system maintenance experience. The system diagnostic routine can be used in several circumstances. For instance, if you have a planned shutdown scheduled and there is a tight time constraint for the procedure, first run the system diagnostic prior to the time of shutdown. This will give you time to clear up any potential issues if they're found. If it runs without issue, then you also know that you should be ready for the planned shutdown when the time comes. Once you execute the system diagnostic function from VXRail Manager, it will produce a report like the screenshot if anything is found. It may also point you to knowledge base articles where you can get more information to resolve the issues. There are two types of replaceable units in the VXRail appliance. One is customer and the other is field replaceable units, CREW and FREW. The customer may replace power supply, hard disk drive, and solid state disk drive. There are videos for each of these available via the EMC Solve Desktop and VXRail Appliance. Please take a moment to examine the table for the VXRail replaceable parts. You can identify a hardware problem by using VXRail Manager. Simply navigate to the Health Physical tabs to see the hardware representation, then select and review the appliance with the potential issue. A CREW is a service part that can be removed and replaced by the customer. The goal is to allow customers to become self-sufficient with self-managing of their infrastructure. Customers will be able to perform power supply and drive replacement procedures. This is an overview of the steps to replace a faulty VCE VXRail appliance component. You want to use the EMC Solve Desktop to generate a procedure for the removal and replacement of the specific component. You need to make sure you are working in a proper static-free area that you know which components need to be replaced. Follow the procedures and return the failed component to EMC. Now let's watch a short video on how to replace a disk.
This video demonstration covers the replacement of a VCE VXRail Appliance hard disk drive. It is not intended as a replacement for the EMC Solve Desktop utility. Always download and generate the latest procedures from the Solve Desktop. Log into the VXRail Manager console and click on the Health and Physical tab. Next, select the disk drive that has the faulted light indicator. Next, you can review the disk information. When ready, select Hardware Replacement and select Continue. The system will start to prepare the ESXi host and then power off the node when completed. Once prompted, you will need to remove the faulted drive and replace it with the replacement disk drive. To remove the disk drive, press the blue button and pull the lever down. Next, remove the faulted drive and place it on a static-free surface. Unpack the replacement disk drive and replace it for the faulted one. Next, reinsert the disk drive into the open slot while pressing it in and then lift up the lever to lock it in position. When that's accomplished, power on the node. When the node is fully powered on, hit the Continue button on the VXRail Manager GUI.
The
Next,
Solve
click on Restart.
desktop provides procedures for common tasks such as crew replacement. Additionally, Solve includes only relevant information for end users, is fully offline capable, and avoids out-of-date content. End users also have access to up-to-date knowledge base content. All relevant information is available to users at the time of the procedure generation. Install Solve Desktop Utility onto your laptop. The supported browsers are IE9, Chrome, and Firefox. There is a known issue with IE8. Users that want to use the direct link should open one of the approved browsers. If you are using IE8, please go to support.emc.com and search for the Solve Desktop. There you will find instructions for using IE8. The Solve Desktop tool will not only provide procedures for common tasks, it will also perform technical reviews by comparing the proposed engagement against known issues using built-in rules. Once you have reviewed the generated procedure for hardware replacement, use the online hardware replacement dialog process in the Solve Desktop procedure to fix the issue. The Solve Desktop produces a Word document with details of the selected procedure. It gives you an option of where to save it along with your chosen options during the creation of the procedure. Always make sure you get a new report even if executing the same procedure, as there may be updates that you want to make sure are included in the generated procedure. Now let's watch a short video on how to replace a power supply.
This video demonstration covers the replacement of a VCE VXRail Appliance power supply. It is not intended as a replacement for the EMC Solve Desktop utility. Always download and generate the latest procedures from the Solve Desktop utility. Log into the VXRail Manager console and click on the Health and Physical tab. And select the appliance that has faulted. Next, select the power supply and review the information on that power supply. To remove the power supply, remove the power cord cable, and then while pressing the blue tab to your left, pull out the power supply. On a static-free surface, unpack the new power supply unit. When ready, insert the power supply into the unit, pushing all the way in until the blue tab clicks to the right. Next, reinsert the power cord into the power supply unit. Refresh the page in the VXRail Manager extension page until the power supply no longer is reported as failed. Next, repackage the faulted power supply and return to EMC following normal procedures. This concludes the demonstration on how to replace a power supply unit in a VCE VXRail appliance.
There are certain hardware units that are replaceable only by EMC field personnel. They are the compute node and the fan. Please contact EMC support if there is an issue with either of these. VXRail Manager supports automated cluster scale-out of an appliance or node for easy expansion. You can also add additional disks, which we will discuss in the upcoming slides. For compute node expansion, VXRail Manager automatically detects new nodes as they come online. All scale-out are performed one node at a time, even when adding a whole appliance. Work with your EMC, VCE, or partner representative to expand your VXRail appliance cluster. For scale-out, VXRail Manager uses VMware Loudmouth auto discovery capabilities based on the RFC recognized Zero Network Configuration Protocol. It automatically discovers and configures appliances on your network. Loudmouth runs on each ESXi host and in the VXRail Manager virtual machine. Loudmouth allows VXRail Manager to discover all the nodes and automate the configuration. Loudmouth requires IPv6 multicast. The IPv6 multicast communication is strictly limited to the management VLAN that the nodes use for communication. Using Ruby vSphere console, you can proactively kick off a rebalance after adding or replacing a node. The perfect time to do this would be part of the addition of a new VXRail node. Scheduling this at the same time, you can minimize any effects on the environment. In order to add drives, there are certain prerequisites as shown here on this slide. Additionally, drives must be added in a balanced manner across all nodes in the appliance. Failure to keep drive counts balanced across nodes could result in a data unavailable or data loss event if there is a node failure of the node with a higher drive count. The drives need to be installed, must have been supplied by EMC, and must not have been previously used in any system. If the drive has any signature or file system previously configured, then the drive add procedure will fail to complete. The VXRail appliance was built for seamless scalability and to be extremely flexible. The scalability within the appliance must remain balanced. The following VXRail foundational rules apply when creating and scale out of a VCE VXRail appliance. For an initial scale out, all 4 compute nodes must be in place prior to adding additional nodes. Always follow the latest procedure from the EMC Solve desktop utility. In summary, we discussed how VXRail system maintenance is a non-disruptive process. You learned that a customer can execute certain hardware replacements and procedures, and other failed components will be handled by EMC field representative. Diagnostics are run at cluster shutdown, but you can also run them for an overall system health check. VXRail can also scale out, and EMC will work with the customer to make this happen. Thank you.
You must pass the assessment with 80% accuracy or greater.